Good morning. Today we are going to see a topic in operations research, linear programming problem. Linear programming problem is otherwise known as linear optimization, may be defined as the problem of maximizing or minimizing a linear function that is subjected to linear constraints. The constraints may be equalities or inequalities. The optimization problem involves the calculation of profit and loss. The main objective is to maximize the profit and minimize the loss. Linear programming problem are an important class of optimization problem that helps to find the feasible region and optimize the solution in order to have a highest or lowest value of the function. In other words, LPP is considered as an optimization method to maximize or minimize the objective function of the given mathematical model with the set of constraints. The constraints may be of inequalities and equalities. The main aim of linear programming is to find an optimal solution of the given problem. Here I am going to solve an LPP by using a graphical method. There are so many methods to solve an LPP. Here I have used a graphical method. For using graphical method, we have to follow the algorithm which have stated for the graphical method. First, we have to formulate the linear programming problem. First, we have to formulate the objective function. Next, subject to the constraints. And finally, non-negative restriction. Linear programming problem involves only two variables. If it consider only two variables, then only we can solve the problem by using a graphical method. If the problem is three or more variables, graphical method will be impractical. The following algorithm. Step 1, we have to state the problem mathematically. That is, we have to write the problem in an LPP model. Second step, we have to write all the constraints in the form of equations and we have to draw the graph for that equation. The graph plotting points will be marked and that region is said to be a feasible region. We have to find the coordinates, that is the corner points of the feasible region. We have to find the intersecting point. For that, we are going to use an elimination method for solving the linear equation. By substituting these corner points in the objective function, we will get the value of an objective function. If the question is based on maximum, we will optimize our solution with maximum. If the question is minimi, we will optimize our value to the minimum value. Let's see one problem using graphical method. My problem is solve the following LPP graphical method. My objective function is minimum z is equal to 5x1 plus 4x2. My subject to the constraint is 4x1 plus x2 greater than or equal to 40 and 2x1 plus 3x2 greater than or is equal to 90. And my non-negative restriction is x1, x2 greater than or equal to 0. Here they have given the objective function subject to the constraints and non-negative restriction. I am going to find the points for plotting in the graph. First, we have to write the inequalities to equality function. Here there are two decision variables x1 and x2. Consider the inequality equations as equality equations by 4x1 plus x2 equal to 40. Similarly, 2x1 plus 3x2 equal to 90. I am going to substitute x1 is equal to 0 in first equation. I will get the value as 0, 40. Similarly, if I substitute x2 equal to 0, I will get x1 equal to 10. So my point is 0, 40 and 10, 0 for the first equation. Similarly, while substituting x1 equal to 0 and x2 equal to 0 in the equation 2, I will get the point 0, 30 and 45, 30. Now I am going to plot these 4 points in the graph. Here I have plotted my equation 0, 40, 0, 30, 10, 0, 45, 0. Here I have marked the intersecting point as B. I have to find the value of B, so I am going to eliminate the x1 and x2. I will get the value 3, 28. So my feasible region is minimum. The feasible region is obtained at the point x1 equal to 3 and x2 is equal to 28. Now I want to find the optimum solution. So I am going to substitute my corner points in the objective function. My objective function is 5x1 plus 4x2. If I substitute my corner points, I will get the value as 225. For the point 3, 28, I will get 127. For the point 0, 40, I get 160. Here they are discussing about the minimum objective function. Therefore, the minimum value is 127. It is obtained at the corner point of 3, 28. Hence, my optimal solution is x1 equal to 3, x2 is equal to 28 and z is equal to 127. This is how we have to solve a LPP by using a graphical method. Thank you.